22. 8 days left, guys. 8 days left. We're coming close to the end here. So we're looking at this worksheet. We've been graphing systems of equations. So let's go over some of these together. For number 1, let me grab my colors. Okay. First thing that we should do is what? What should we do first? Y-intercept. Let's go ahead and just circle both of them. I've got a positive 0.5. And what's this one?
A -4.
Good. A -4. Now let's identify our slopes. Then we'll graph them both. What's our slope for the first equation?
1 over
Good. 1 over 4. And what about for the second one?
-2 over 1.
Yes. -2 over 1. Okay. So now let's graph our 2 lines. The first one in green, I'll call it A. So my first point is my y-intercept. So where is that going to go?
Between 0 and 1.
Between 0 and 1, the positive
Right
direction. Right here. Good. And here, these are so tiny. I'm going to zoom in as much as I can. Let's see. Am I recording? Let's check. I think I am.
I don't see the little tiny.
Yes, I am.
Good.
Hey, it's always good to check. Always good to check. Okay, so we have our y-intercept, our 0.5. How do I use my slope to find the next point?
Oh, you go up 1 and over 4.
Good. So my rise is 1, so I'm going to go up 1, which will be right in between 1 and 2. And then over to the right, 4 spaces. 1, 2, 3, 4. So right here, your first line should be going through these 2 points. Okay, so let me get my ruler out. And we will trace. Make sure we get it about right. Line A. Okay. Now let's look at our second equation. Call that B. So where's our first point go?
-4.
Good. On the y-axis, -4. So we go down 4 right here. And how do we use the slope to find the next point?
Go down 2.
Good. Go down 2. 1, 2. And
Over 1.
over 1. Good. Over 1. Right about here. Now let's talk again about what we could do since this goes off the graph. So if our slope is -2 over 1, how else could I write this to be the same number if I wanted to, instead of going down 2, what if I wanted to go up 2? What would I do with my 1? Make it a negative. We can just move that negative. So instead of going down 2 off the graph, we could just go up 2. And now since our 1 is negative, do I go to the right or the left?
Right.
To the left this time. Since if we have our -1, yes, we're just switching everything. We're going up instead of down. We're going left instead of right. So over 1. And as you see, that point falls on the line as well. That will work just as well as the other one. So let's connect our dots. And what's our solution?
-2.10.
Yes. So technically, the exact solution is, it's going to be whole numbers.
-2 and 0.
Yes, it'll just be x is -2. I'm going over 1, 2 right there. 2 And I'm not going up or down, so my y is 0. Perfect. Okay, any questions about number 1? All right. Can I move to number 2?
Yeah.
All right, let's look at number 2 then. So, number 2. What's the first thing we look at?
The y.
The y-intercept. I've got a 2 and a -5. What are our slopes?
-2 over 1. 2 over 1.
Good.
The 1 over 3.
-2 over 1 and 1 over 3. So let's start with the first equation. We'll call that A. Oh, I forgot to label that one B. I guess I did color code it, so it's not that big a deal. Okay. So where's my first point for equation A?
+2.
+2. Yes, on the y-axis. Wonderful. And how do I find my second point?
Go down 2 and over 1.
Good. Down 2 over 1. Wonderful. There's our first line. Connect the dots.
So I learned something yesterday.
What'd you learn?
That, because I thought the whole fraction is supposed to be negative, but the denominator is never negative, it's a positive.
Yes, yes. So what kind of number would it be if both numbers were negative? Positive or negative total?
Positive.
It would be positive. So just like we did.
I was so waiting on you to say that.
That's all right. Here. I didn't ask that question very
Because
well.
I thought I was supposed to do -2, or if I was doing this yesterday, I thought I would go -2 and then go -1. Because it's a negative on the side of the fraction.
Yes.
But it's not. It's always a positive.
Yeah, I did that on the one.
So if I have -2 as my number, and I divide it by -1, that actually turns this into a +2, because a negative divided by a negative makes a positive. So we don't want to do that. We put our slope over +1 so that it stays a -2 like it was from the beginning here. So that's why we can also, if we have a positive slope and it's going to go off the graph, we could make both of the numbers negative and use that instead. And I'll explain that in context when we have one to look at.
Okay.
So, wonderful. There is our A. Let's graph B now. All right, thank you, Tasha. -5 is that first point, so we're going to go down to -5 here. And what's our rise over run?
1 over 3. So
Good.
You go
Up,
up 1 and over
1 over 1, 2, 3.
Boom, shaka.
Yes. Boom, shaka.
Yeah.
3. All right.
All right, connect the dots.
Connect the dots.
Here we go. What's our solution?
Is 3 and -4.
Good. Yes, over 3. That's where it lines up with 3 on the x-axis. And it lines up with -4 on the y-axis. 3, -4. Good. Hi. Any questions about number 2? Leave this up for a minute. Does anybody still need this? Anybody still copying down? Can we move to number 3?
Mm-hmm.
Okay, wonderful. Let's do that.
We're already in.
Okay, number 3. We did do this one on the board, but we didn't record it, so we can run through it again real quick. So number 3, we've got A and B. I already got my red one in my hand, so. Okay, so speed run. We did already do it. That's all right. What's our y-intercepts?
-3 and 4.
Good, -3, +4. And our slopes?
-3 over 1 and 4 over 1.
Good, -3 over 1 and +4 over 1. So let's start with A. Where's our first point?
-3.
Good, -3. So we'll go down 1 to -3. And how do we find that next point?
You go down -3
Mm-hmm.
over 1.
2, 3 over 1. So we could do that way. If we don't want to go off the graph, what's the other way we could write our slope?
+3, -1.
Yes, instead of -3, +1, we could do +3, -1. So we could go up 1, 2, 3, and to the left, -1. Still falls on our graph, works just the same. Connect the dots. Mhm. Okay. Look at the second equation. Where does my first point go?
+4.
+4. 1, 2, 3, 4, right here. And this slope is going to be way off the graph, isn't it?
Yes, it is.
Yeah, if I try to go up 4 from here, it'll go 1, 2, 3, 4. I'm going to be all over the place.
So you can make them both a negative?
Yes. So remember, 4 over 1, these are two positive numbers. If I do 4 divided by 1, I get +4. I could also do -4 divided by -1, and that's all going to give me that +4. You can check on your calculator too if you're unsure. Here. So 4 divided by 1 is 4. -4 divided by -1, also 4. It will work. So instead of going up 4, let's go down 4. 1, 2, 3, 4. And when I go over 1, do I go to the right or the left?
Left.
Left, since it's negative now. And look at that, we land right on there. So let's connect the dots and write in our solution.
-1, 0.
-1, 0. Good. So that's our solution right here with an x value of -1. And we didn't go off of the x-axis. We're not going up or down. So our y value is 0. All right. Any more questions about number 3? Anybody need this work still, or can we move forward?
We can move forward.
Okay. All right. Let's look at 4. Okay, we got same kind of equations happening here. A and B. What are the y-intercepts?
1 and -3.
Good. 1. -3. What are our slopes?
-3 over 2. And 1 over 2.
Good. -3 over 2 and 1 over 2. So let's start with A. First point goes where?
1, +1.
+1 on the y-axis and
Down 3.
Down 3.
good.
So
Down
-2.
3. 1, 2, 3.
Over 2.
Over 2. 1, 2. There's A. Connect the dots. Go. And now let's do B. Where's our first point?
-3.
Good. -3. 1, 2, 3. And where do we go from here?
We go up 1 over 2.
Good. Up 1 over 2 lands perfectly on that other point.
Ooh.
Yes, so we're going to connect the dots again.
2 and 1.
2, -2.
Let's see.
It's -2, 2.
Okay, let's see where it lines up. I'm going to tell you, Riri, you're right.
Yeah, that's what I got.
If I see where my intersection lines up on the x-axis, it lines up at positive 2, right?
Yeah.
How about the y?
Oh, I'm on the wrong.
Negative 2. We're still on number 4.
I'm on
Yeah.
5. Oh, please.
So,
I'm sorry,
what's our
but-
coordinate?
2, -2.
2, negative 2.
Hot dog.
Good.
I was scared for a second.
Okay. Anybody still need this work? Still writing this, Tasha?
Oh, I am.
Okay, take your time. You just tell me when you're ready. We'll go to number 5.
I'm
guys.
ready. I just want to make sure. the parts
Okay,
right.
perfect. All right, number 5. Y-intercepts, what are they?
Negative 4 and 3.
Good. Negative 4 and 3, and our slopes?
5
5
over
over
2
2.
and
Oh.
Negative.
negative
one.
1 over 1.
Oh, yes. Remember, if x is by itself, there's an invisible 1 there. So since it's a negative x, it's a negative 1 over 1. Good. Negative 1 over 1. So let's start with our first equation, A.
Negative 4.
Good. First point down here, negative 4. And where do we go from here?
Up 5.
Over
Good. Up 1, 2, 3, 4, 5 over 2. 1, 2. There it is. Okay. You guys are doing great with this. Okay. Now let's do B. Where's our starting point?
Positive 3.
Good. Positive 3. And where do we go from here?
Down 1 over 1.
Perfect. Down 1 over 1. Right here. Okay. Next one.
Two and 1.
Good. So let's circle the solution, see where it is. Michael, you are right.
You're such a smart kid.
Lines up with positive 2 for the x, positive 1 for the y. Good. Very good. Man, we're just flying through this worksheet. Okay. Let's look at number 6
Oh,
next.
it's 2 and 0. I'm tripping.
Y-intercepts.
2 and 2.
2 and 2. So let me tell you a little trick. If the y-intercept is the same,
It's going to be the same point.
it's going to be the same point. That means both equations are starting at plus 2. That's going to be our solution. So we could just write the solution, but let's solve it out first. Let's make sure we understand why. What's our slopes?
The y would be 2.
1 over 3 and negative 1 over 2.
Good. 1 over 3 and then negative 1 over 2. So we will do A first. We already know that the starting point is at y equals 2.
Yeah, up 1 over 3.
Good. Up 1 over 1, 2, 3.
3.
Perfect. There's our A.
Makes more sense when we do it together.
Yes. Yes.
So isn't the solution 0, 2?
Yes, it is.
Oh, I see that 2, 2. I think.
Perfect. Okay, now let's look at the second equation. Make the second line. We've got the same starting point. We started at 2. So now we just use our slope.
Go down.
Down 1 over 2.
Down 1 over 2. And look at that. We already know the solution because they start on the same point. So they share a y-intercept.
So it's 2 and 2.
2 and 0.
0, 2.
0 and 2.
So 2 is our y value,
That don't make sense.
right?
We're on the y line.
So here, let's talk about how we get this coordinate. We have this point. We want to see where is it lining up with on the y-axis. So our y-axis is the one that goes up and down right here. And it is on 1, 2, touching the y-axis, right? Now, the x-axis, we know, is the one that goes left to right. This point isn't moving left or right. It's right in the middle on x equals 0, right? The midpoint of this is 0. Because if we went over 1 to the right, we're at x equals 1. If we want 1 over to the left, we're at x equals -1. So if we're in the middle and on the line, x is 0. So when we write our coordinate, remember we have the x value that comes first. The y value comes second. So where does this line up on the x-axis?
0.
0. So that's
Plus
our
0.
0. And on the
So what was the point in
y-axis,
connecting them?
say that one more time.
What was the point in connecting them?
The point in connecting them is seeing where they intersect. So for this one, we said from the beginning, since they both have the same y-intercept here, we know that this is going to be where they connect. But we just wanted to draw the lines to show that it does work. That it does work by just looking at the y-intercept.
So you still gonna mark around if you put 2 and 2 because it says 2 and 2. It don't have no dot on the 0.
The 2 is on the or B.
So 2, 2, let me show you this. Let's see.
This don't make no sense. Your answer right now.
Okay, so look. Here is a point. Watch this.
Doesn't make no sense.
Look, this is a point, and it is lining up with 1 on the x-axis and 1 on the y-axis. This point would be 1, 1. If I go over 1, now I'm at 2 on the x-axis, and I'm still at 1 on the y-axis. Over another 3 on the x-axis, still 1 on the y. Let's go up. If I go up 1, I'm still at 3 on the x. Now I'm at 2 on the y.
3, 2.
3, 2. Okay. If I keep going back more here, now I'm at 2 on the x-axis, and I'm still at 2 on the y. If I go back even more, where am I on the x-axis? 1. I'm at 1 on the x. Where am I on the y-axis? 2. What if I go back even 1 more right here? Where am I on the x?
You're going to be on 0.
0. This is 0.
So anytime you
Y
have
is 2.
both of you, if both of the y-axes are the same, it's always going to be 0 for x.
Yes.
Okay, I wish you would just say that because you just confused me even more.
Okay.
Thank you.
Mm-hmm. So, our y-intercept, if you also remember when we were identifying parts of a parabola, our y-intercept was always 0 for the x and then a number for y. So the y-intercept, you're just finding the number of y. It's on 2 for the y, and the missing number is going to be 0.
Okay. So number 7 is 0.
Yeah, number 7, because our y-intercept is
-3.
-3
Yeah.
for both. What's our solution? 0, -3.
Y'all didn't even graph it yet.
Yeah, we didn't even have to graph it. They got the same intercept.
But if you do want to graph it, it's gonna be a little tricky.
Yes, let's graph it though. Let's graph it.
That's so like shut up.
Hey, we're learning. Y'all are doing good.
She be extra sometimes.
Okay, what's our slopes?
-3. No,
Oh.
sorry, -4 over 9
Yes.
and
And
-7 over 5.
Good. -4 over 9, -7 over 5.
We're gonna flop that.
Yeah.
Big.
Okay, so let's look. A, we have -3 is our starting point for both of them. And our slope is -4
Make that-
over
negative.
+9.
Are we going up 4 though? Or are we going down 4?
We should be
So
going down
if
for
we
it.
do it the way it's
Oh, we're going
written,
up.
-4 over 9, we would be going down 4, 1, 2, 3-ish, 4-ish. And then we'd have to go to the right 9 spaces. There's 5, 6, 7, 8, 9. Oh my lord.
Yeah.
That's too far away. So let's mess with this a little.
Go up 4 and over 9.
Okay, yeah, let's start with that.
Still gonna be off, but
4
you should gonna be off.
and -9, so we could go up 1, 2, 3, 4. Okay, so it's gonna line up here, and then over 9. So there's over
Negative
5, 6, 7, 8, 9. Oh my gosh! Either way, it's gonna be really far off.
I just created my
So-
own graph.
Say that again,
I just
Mike.
created my own graph.
You created your own graph. You could create your own graph, absolutely. Now, Erica discovered something really interesting that you can do. So would you mind sharing that with everybody?
Sure. So what you can do is you can take the top number and bottom number and divide them by the same amount. For
Uh-huh.
example, divided by 2, you would get -2 over 4.5. Or you could divide it further by 4 and get -1 over 2.25.
Yeah, okay. So this is a fraction, right? Normally, I'm going to encourage you not to put decimals in your fractions, but in this case, it's a good idea to. So because our point is going to go so far off the graph, it would help us to maybe take this or this and divide by 2. So -4 divided by 2 is -2. 9 divided by 2 is 4.5. So we could do that. Now, I want to preface this with, I'm not going to expect you to remember how to do this. I won't give you a problem like this on the quiz, but this is still good to know if you ever need it in life for whatever reason. Okay, so let's go down 2 and over 4.5. 1, 2, 4.5.
Yeah, right.
There it is. Okay. And similar thing is going to happen with that next point. Or maybe it won't, since it's down. No, it will.
The next one's at the top though, right?
Yeah. Let's look at it.
For B, I have -1.4 over 1.
So just go.
That would work too.
That is a lot of
Okay.
changing whatever.
So luckily, this is one where they've got the same y-intercept, so technically we wouldn't have to graph it at all. We can look and see, okay, they're gonna be intersecting here. But if we did want to graph it, we could be using this crazy method. I think it's great, pretty brilliant, if you ask me. I think it's smart to be able to do that. So here's B. We started at -3, and instead of going down 7 over 5 to the right, we could go up 7 over 5 to the left. So 1, 2, 3, 4, 5, 6, 7, and then over 5. And there's our lines. Woo. There we go. Okay. So if number 7 has got you a little lost, don't worry.
Oh boy.
Don't worry. I'm not going to give you one like
Mine was going
this.
the other way for some reason. I don't know.
That's what I did too. That was-
Which one of your lines, the top or the bottom? Or A or B?
Shit, I don't know. My thing looks like that, but it's going the other
Get a
way.
star.
I'd have to look at it. I can look at it here in a bit. We're gonna go ahead and move on though, because this was kind of a special problem that I won't be giving you in the future. Should have looked at the paper beforehand. The answer key makes it look like they're all very nice. Cause I look at it and I'm like, oh, they're all on the graph, but I can't see the other point that's way down here. So,
And it's still going.
right.
Follow me.
Okay, let's look at number 8. And once we finish this, we're gonna take a few notes. Okay, here's our y-intercepts, 5 and -1. Slopes, what are they?
1 over 2.
Good.
Column.
Good. 1 over 2, -5 over 2. So let's graph A first. Okay, so our first point goes where?
Positive
Positive 5. And then how do we find the next point?
Over 2.
1/2.
Yeah, you could go up 1 off the graph and over 2. Yes, or we could make them both negative, down 1 over -2 to the left. So let's try that. Down 1 over 1, 2. So either way, here's the up 1, here's the over 2. You're going to get the same line.
You said no, it's okay.
It works.
Yeah, it will work. Let's see. Here's A. And let's find our B line. -1 is our first point, so we start here. And then,
Down 5 over 2.
yes, we could go down 5 over 2
Or up 5/2.
or up 5 to the left. I'm going to do this so it doesn't go off my graph. So
4.
1, 2, 3, 4, 5, yeah, and then over 2. There you go, right on there.
Well,
Perfect. All right, so what's our solution for this one?
-2, 4.
Yes, our x value, our point lines up with -2 on the x-axis and +4 on the y. That's the answer.
had it backwards. I had -4.
I got 0.35. Why? How?
I bet your lines, since some of them went off the graph, they probably just weren't perfectly accurate, and that's okay, as long as it's close enough. How far off was yours?
3.5.
3.5 for your x or your y?
My Y.
Your y. Okay, that's close enough to 4. I bet your line was just tilted slightly different. On graphs that are really tiny like these, your answers are going to probably be a little off, and that's okay. Okay?
Can I get some of these? Take over practice.
Yes, absolutely.
No.
Absolutely.
Oh.
I got plenty more.
Okay.
All right, guys.
Where I need to be is here. No.
Let's get our notes out. We're going to take some notes before lunch.
No, I'm trying to know how to do it.
So I'm going to leave that up while I get my notebook out. In order.
Yeah, when we do finals next week.
Not next week, but the week after.
We gonna be stressed.
No, we won't be stressed.
Especially people with multiple classes. Lord Jesus.
Now that I understand. Ugh. I'll try to make your life as easy as possible in here. Easy as I can. Okay.
Last course on my
You took some
So,
And I want my last course for my certification.
this is Algebra 2. Unit 3, or 2, Unit 2. Yes, it is day 22 for us today.
I'm so cognitive.
And normally I make the do now page 1, but that was a worksheet, so this is going to be our page 1. Page 1. 22. Okay. And we are still talking about systems of equations. So let's title our page with that. And I'm going to say solving systems of equations. Solving systems of equations. So we have learned one way to solve a system of equation. We learned how to do it by graphing and seeing where the lines intersect or cross. So let's write that as our first method by graphing. Follow picture next to it. Substitution. And then write X, Y. So that's the first way to solve a system of equations by graphing. There's two more ways that we're going to talk about. Number two is by something called substitution.
Sorry, I convinced him to
Hello.
come to class.
Yay! And the third way we'll talk about is by elimination. I'm gonna write out some guides for each one so that they make sense. I kind of spaced these out. We're gonna write something small underneath both of them. Let's see. So when we use substitution, this is how I would kind of abbreviate it or show how to do substitution. And then we're gonna go into depth later. What I write might make no sense to you at first, and that is okay. I'm not really giving you the explanation yet. So we have y equals mx plus b, and another y equals mx plus b. So what we end up doing to solve for the solution here is this. Since both of these are equal to y, and again, it's okay if this confuses you at first. We'll just do mx plus b equals n plus b. So for x. There's our little substitution guide, and then I'm going to show you an elimination guide. So we'll probably be spending all of after lunch talking about both of these. So for elimination, we have a different equation, ax plus by equals c. Another ax plus by equals c. What we do for elimination is turn it into an addition problem and try to get rid of X or Y. Again, it's okay that probably makes no sense. It will soon. So I'm going to write eliminate X or Y. This will be our little guide. And then I'm going to actually start a new page after this so that we have lots of room. And we're going to show some examples of substitution first. And I'm aware of the time. We've got a little bit of time left. I want to show you at least before we go. We have a few people still writing.
Yes, 1 second.
No, you're all right. Take your time.
We're having a much better time with this than I do graphic.
Really?
I hate graphic.
It's funny. Everyone is one or the other. You either love working with equations or you hate it, and you either love graphing or you hate it.
Well, we all hate math,
What'd you say, Wes?
but everyone agrees, everyone hates math. I don't.
I don't know about that. Not everybody hates
My
math.
sister explicitly loves it, not just absolutely can't stand it. My sister.
Okay, is
My
anybody still writing?
My brain does not hold numbers, so.
Well, that's all right. That's why I don't make you memorize stuff. If you take notes, you'll be good.
Usually fine with the logic of things, it's just the numbers that just disappear.
Right. Okay, so. Page 2. Wanting to continue. Unit 2. So let's talk about substitution first. So to practice substitution, I'm actually going to use, let's do one of the equations off of our paper. We have some nicer numbers. Let's do number 3, because those are all whole numbers. I'm going to start us with y equals negative 3x minus 3. And we also have y equals 4x plus 4. So, just like I said, or I wrote out in our guide, we can see that negative 3x minus 3 is equal to y. We can also see that 4x plus 4 is also equal to y. So if any two values are equal to the same thing, they must be equal to each other. So since these are both equal to y, I can write them as being equal to each other. So I am going to write negative 3x minus 3 equals 4x plus 4. And I'll actually use some colors, see if that helps at all. So once we've got this equation set up, we're just gonna be solving the equation. That'd be as simple as that. So let's make sure we remember how to solve an equation. That's one of the most important basic skills of Algebra 1 and 2 and any other math you'll ever do. Solving equations, it's very important. So I see that I have yes, I have two different terms here with variables. I have an x on both sides of my equation. So before we start trying to solve for x, we want to combine our like terms.
So 1x.
Positive 1.
Yeah, so here, let's see.
Add 3x to both sides.
I'm gonna annotate this.
4x.
Combine like terms.
So we want.
So.
And there's two different ways we could do it. You could either subtract 4x from both sides, or you could add 3x to both sides, right? Which one do we want to do?
Add 3x.
Let's add 3x. In general, we want to avoid negative numbers for x because it's just going to make more steps for us at the end. We'll have to divide by -1 and all of that. So we're going to do the opposite of minus 3x. We're going to do plus 3x. And I am going to write it in orange as well. Plus 3x. Whatever I do to this side, I have to do to this side. Plus 3x. Right? So what happens to my 3x's over here?
They cancel out.
They cancel out. Now what do?
7x.
Yeah, 4x plus 3x is 7x.
So you can't add -3 to +4 to get 1. That's
You can't unless they're on the same side of the equation. Whenever you cross over the equal sign, you always have to use inverse operations. You have to do the opposite. You'll get a funky answer if you don't.
So you bringing everything down to?
Yes.
-3 equals 7x plus 4.
Yes, so bring everything down. -3 equals 7x plus 4. Good. Okay, what do I do next?
Subtract 4.
Subtract 4. I have -3 equals 7x plus 4, and I want to get x by itself. So the next thing that'll probably get me closest to having x by itself is getting rid of that plus 4.
-3 plus 4.
Do the opposite. Remember, if I have plus 4, I do minus 4. So I need to do that to both sides of the equation. What happens to my 4? They cancel out. What is -3 minus 4? -7
Equals 7x.
equals 7x. Good. And what's my last step here?
-7
Good. Divide by
or 7.
7.
I did the opposite way.
That's okay. Either one will give you the same answer. My 7's cancel. -7 divided by +7 is
-1.
-1 equals x. Your x is -1. And if we look at our paper, what number was that? Number 3?
Yeah,
-1.
We got the right answer. Our x value was -1. Perfect. Now, after lunch, we'll plug that in and solve for y. So you guys are free to go. It is lunchtime.
That just sounds more confusing.
We will talk more after lunch. I'm gonna pause the video. Okay, so we are back from lunch. Here's where we left off. we started by setting negative 3x minus 3 equal to 4x plus 4, and then we solved for x. So we know that that is correct because we took this problem off of number 3 on that worksheet, and our x value and our coordinate is negative 1. So if we do the next part correctly, the value we get for y should be 0. So let's try. So now that we know x is negative 1, does anybody have an idea of how we could solve for y?
Plug number to X.
Yes. So because both of these equations are going to have the same solution, we're finding where they intersect, we can use either one to solve for y. We'll get the same answer. So let's actually do it with both just to show that. So if x is negative 1, then I'm going to write here, let's make a little step. I'm actually going to annotate this. Sometimes I say things and then you understand it in the moment, and you look at your notes later and you're like, what did he do here? So we solved for x. Then we're going to plug in the value of x, which in this case is negative 1. Plug in the value of x to solve for y. Okay. So we have two equations that we could do this with. We have y equals negative 3 times x minus 3. And we have y equals 4 times x plus 4. So we know our x is negative 1, so let's plug that in, being very careful with our signs. Negative 1, negative 1. And Tasha, what you just missed is before lunch we solved for x.
Mm-hmm.
We already did that. So we just wrote out those steps to make sure that we remember when we look back at our notes. First, we solved for x.
Number 1 equals X was the answer to that.
Yes, x was
Okay.
negative 1. So now what we're doing is we're taking our original equations here and we are just rewriting them, but instead of negative 3x minus 3, we're going to plug in our x here. Negative 3 times negative 1 minus 3. And same with the other equation. You don't have to do it with both. You could just pick one, but I'm just showing that both will work.
Perfect.
Mhm.
All right. Let me write that down. Thank you so much.
Yes, of course. Okay, so let's start with the first one here. Y equals negative 3 times negative 1 minus 3. So what do we do first here?
Let's multiply it out.
Yeah, what's negative 3 times negative 1?
3.
That was just a three.
Positive 3. So now I've got y equals, I used this, so I'm going to cross it off. And I know that it's positive 3. And we need to bring the rest of the equation down. We still have minus 3. So what do we do here?
3 minus 3.
Yeah, 3 minus 3, which is
0.
0. That's our answer for y. And we could check our graph that we did for number 3, and that's absolutely correct. Our y value is 0, so we know we did it right. Pretty cool. So just to show you that both equations will work, let's do the second one as well. Y equals 4 times -1 plus 4. What's 4 times -1? Good. -4 plus 4. And what's -4 plus 4? 0. Both of these work. So we got a value of x, which is -1, and then we got our y value, which is 0. So our final answer, we want to write it as a coordinate. Make our parentheses. What's our x value again? Good, -1, and our y, 0. That is the answer. Final solution. And we're going to do some more of these together.
I just need to write this down.
That's all right. Take your time. Take your time. I'll leave it up for a minute.
I looked at my phone.
All right. So that's our answer for this question. Let's start a new page. We kind of spread that problem out. It looks like a lot.
Yeah.
Moving on. So I'm gonna title my new page. Algebra 2. Unit 2. And this is page 3 of our note. Still day 22. Let's see. Let's pull another one from the worksheet. We'll do that while we're practicing, just so we can make sure that we can check our answers. So I'm also gonna title this one Substitution again, so that when I look back at my notes, I know what method I'm using and I can reference it later on when I need to. And let's look at number 2 on the worksheet. Number 2. So I'm going to write y equals -2x plus 2. And y equals 1/3 x minus 5. So whenever we are using substitution, remember we're looking at these two different sort of values. We've got, let me get that color out again. Color that I use. We have -2x plus 2 set equal to y. And we've got 1/3 x minus 5 equal to y. And if two values are equal to the same thing, they must be equal to each other. They must be the same. They must be equal. So let's do like what we did here. and set them equal to each other. Doesn't matter which one you write first. I'm gonna write this one first just because it's on the top. So negative 2x plus 2 equals 1/3 x minus 5. Now, sometimes when solving for variables and equations, I find that fractions are not super fun to work with. It throws me off. If you love fractions, that's great. You can keep it like this. However, I'm going to change it to a decimal. So you guys remember when we were doing probability and we would get a fraction and turn it to a decimal?
1 divided by 3.
Yeah, we're just going to do that in our calculator.
0.33.
Yes. 1 divided by 3. We're going to get 0.3 repeating. So instead of 1/3 x, again, you could keep it like that. I'm going to rewrite my equation and write 0.3 repeating instead. So negative 2x plus 2 equals 0.3 repeating x minus 5. So I just changed my fraction to a decimal. That's all we did there. Don't have to do it, but you can if you want. All right. What should we do first when we have variables on both sides? Go ahead.
Rainbow?
Rainbow?
Add 2x to both sides.
Yeah, we could add 2x to both sides. Absolutely. So we've got minus 2x, add 2x.
So it'll be 2.3.
Yes. Yeah, 2.3x. So our minus 2x and our plus 2x, what happens there? They cancel out. They cancel out. I'm going to bring everything else down. I've got 2 left equals 2 plus 0.3 repeating is 2.3 repeating x minus 5.
Plus 5 to both sides.
Yep, now we just add 5 to both sides. Plus 5, plus 5.
7 equals 2.3.
Yes. 2 plus 5 is 7 equals, those are canceled, forgot to say that. 2.3 repeating x.
Now we divide.
Now we divide. Divide by 2.3 repeating. Now, if you want to get that 0.3 repeating in your calculator, the only really way to do it that I know of is typing in 1 divided by 3. So what I would say is if you want to get the most accurate answer, when you do 7 divided by 2.3, 7 divided by 2.3, I would just put as many 3s as it'll let you at the end. Okay, well, maybe not as many as it'll let you. It'll let you really do a lot. I didn't realize
It's
that.
all equals 30.
It comes out to very
right.
close to 3.
Yeah, 3. You put
It's
enough
three.
3s, you'll get 3. Nice. So,
X equals 3.
3 is our x value. Pretty cool.
Slightly more than 3, but
Yes, slightly more than 3, but
If I may,
yes.
if you do keep it in the fraction form, you can use the fraction in parentheses when you're
Yes.
dividing to get 3.
Yes, you can. Absolutely can. So, quick refresher, if you guys want to remember how to put a fraction in your calculator. Let me get my calculator, because mine won't let me do fractions for some reason. Some of the calculators we got have a few issues, and That's okay. So some of your calculators, if they don't let you do a fraction, let me know and we can get you a different one. But to make a fraction, this is how to do it. You hit the alpha button, the green alpha. Oh, you'll see the little A pop up on your screen. Then you hit Y equals, which is at the very top under the screen to the far left. And then you're gonna see this little menu come up. Then you hit the enter button. And now you have these two nice little boxes where you can type fraction in. So whenever you do type a fraction in, I'll type in 1. To get to the denominator, the bottom slot, you use the arrow keys. If you hit enter, it will give you an error message. So you need to hit down arrow and then 3. There's your fraction. So I can do 7 divided by arrow up to 1/3. Wait a minute. That wasn't the problem. Okay, so it would actually be 2 times 3. 7 divided by 7/3. Work in my head. Hang on. Alpha Y, enter 7. Okay, so 7 divided by. Yes, there we go. There we go. Or 2 1/3. 2 1/3 is equal to 7/3. If you're wondering why I wrote that. Okay. Or you could just do decimals. Fractions tend to scare some people. I don't know, they always freak me out, but if you're careful, you can do them. Okay, do we have any questions
Which
about?
equation are we doing?
We're on number. Let me see, which number
We're
was
on
it?
2?
Number 2 on the worksheet. Yes. We got 3 for X, and that's right. Pretty cool. Okay, so what do we need to do now that we have our X?
Plugging that X into your equation.
Yes, we want to solve for Y by plugging X into the equation. So which one of these equations would we like to use? We can do either one.
The first one.
Yes, let's avoid fractions. So we have, yes, bless you.
-2.
Y equals -2 times X plus 2. And X is 3. So, yes, Y equals -6 plus 2. Y equals -4.
And your X was 3.
And your X is 3. So our answer is right. And how do we write it?
3 first.
Yes.
X value first, Y second.
Your X is first, your Y is second. 3 -4. Very nice. Very, very nice. Okay. Anybody still writing this? You ready to need it? No. Let's do another one together. Let's look at how about number 1 on the worksheet? Label it. This is number 1. So we're gonna do Y equals 1/4 X, or 1/4 is 0.25. I'm gonna do it as a decimal. Plus 0.5. And the second equation is Y equals -2X minus 4. Okay. So what is our first step here.
Make it into an equation.
Yes, we want to turn this into a equation, a single equation. What's that equation gonna look like?
0.25x plus 0.5 equals negative 2x minus 4.
0.25x plus 0.5 equals negative 2x minus 4. Okay. Our equation is set up. Now we just solve for x. So, what do we want to do first?
Subtract 2.5 from both sides.
Let's do that. Minus 0.25x minus 25x. That's what you said to do, right?
Yes.
Okay, good. Making sure I heard you right. Okay, so the 0.25x is cancel on the left side of the equation. And what is negative 2 minus 0.25?
Negative
2.
1.7.
Ooh, so if it was a positive 2x, it would be.
Oh.
But it's a negative 2x.
Negative 2.25.
Yes. So whenever you subtract from a negative number, it's just making the negative number bigger. It's like doing negative 2 plus negative 0.25. So we've got negative 2.25x. And then we bring everything down.
Negative 4.
Minus 4. What else do I need to bring down?
Equals and 5.
Good. The 0.5. 0.5. And this is why a lot of times I suggest putting a 0 before your decimal, because I bet it would be very easy to forget that that's not just a 5, a whole number 5. Putting the 0 there makes it, at least for me, it helps me remember it's a decimal. Okay. What do we do now?
Subtract 4. Add both 4 to
Yes, we're going to add 4. Since it's minus 4, we got to do the opposite. Plus 4 to both sides of our equation.
And cancel the 4s.
Equals
Yes, cancel the 4.
4.5 equals negative 2.25.
Perfect. 4.5 equals negative 2.25x. That last step.
Divide
Good. Divide by negative
2.25.
2.25. Both sides. And 2.25 is canceling. So I'm left with x by itself.
Negative 2.
Yeah, I bet you're right. 4.5 divided by negative 2.5. Sure is negative 2. Perfect.
So negative
And
2
that
equals
matches
x.
x on the graph.
Yes. That was number 1. Number 1 is negative 2 for x.
Now plug it in.
Yes, now we just plug it into which equation we want to do.
First, second one.
Yeah, let's do the second equation.
Is this going to be on the test?
Yes.
Oh
Yes.
my God.
Negative 2
Sure will.
times negative 2 is positive 4.
Do more practice on it though, right?
Yeah.
Oh.
Okay, so y equals negative 2 times
Times
x minus 4.
Negative 2
Yes.
times negative 2 is negative 4. Or positive.
Positive
Positive
4.
4.
Negative times a negative makes a
So
positive.
4 plus negative 4 is 0.
0.
It is 0. And what do you know? Y is 0. That's pretty good. So what's our coordinate?
Negative 2, 0.
Good. Negative 2, 0 in parentheses. Right.
Please don't make this part of the exit ticket. For sure.
I
think it's
already set in stone.
Right. That's gonna be my first bad exit.
That's okay, because I think sometimes the first time you learn something or you try to learn something, it makes no sense at all sometimes. And then, you make tons of mistakes and then you fix the mistakes later on. And I'm gonna encourage you and anyone else that is feeling a little iffy about this, please come in tomorrow. Tomorrow's Friday. I'm here. It'll be just me and you, and we can talk. We can do lots of practice together. Okay? I want to help. I want to help.
Last time I came, I couldn't concentrate.
Mm.
Well, I'm big how I'm going between you and Miss Leslie.
Yeah.
So I'm
It's
just
not
see
you,
you. I'm
just
see you
just
first or
talking.
Miss Leslie first. I got more of her rules, so
Mm.
I'll be over here afterwards.
Okay. Anybody still need this? Can I move on?
Mm-hmm.
All right.
What we're doing is relative.
Yes, ma'am. Solve for X, plug in X dot.
Four.
I think this page right here is what makes it difficult. But what the hell is this? But I understand when we solve it, but I don't know what this is.
What is it that you didn't understand?
When we wrote down the notes for this, the first page,
Oh, the first page.
with the
So
equations and stuff, and by eliminating, this is what we're doing, right?
this is what we're doing. So yeah, let's look at what we just did. We're
That right
doing
there.
substitution right now. What we're doing is exactly what we wrote previously. Y equals mx plus b. We're taking the second half of that equation for both, and we're setting them equal to each other. So once you understand the process, looking back at this can feel like a reminder of, oh yeah, I set the second half of the equation equal to each other.
Didn't we tutor it or something like this on Algebra 1?
We
but you
did
said
do this
we're
in
gonna
Algebra
do it?
1.
All right.
Yes, but it was bonus questions.
Yeah,
in
yeah,
Algebra
that's what
1.
I'm saying. It wasn't this right now.
Yes, now we're doing it.
Yes, that way.
Now we're doing it. Okay, let's try one.
Just remember going over elimination.
Yes, we did do eliminate. Well, we did both of these. It's just we didn't spend very much time on them.
I don't remember elimination at all.
Really. Well, I might jog your memory a little when we do one. Let's see. Let's do.
You worked with the technique, so good. You scared her. You said.
More substitution.
She said that?
Let's do number 8 together. So for number 8, we have y equals 1/2 x plus 5. So we could write the fraction or we could write the decimal. I'm going to write the decimal if everybody's okay with that. 0.5 x plus 5. And y equals -5/2.
2.5.
Yeah, -2.5. I should know that. -2.5 x minus 1. Okay. So,
Equals -2.
so here's people saying we're going to take them and set them equal to each other. 0.5 x plus 5 equals -2.5 x minus 1.
Can I ask a question?
Uh-huh.
When you're doing this, so the one on the bottom goes at the end, and the one at the top goes in front. When you're making the equation or whatever.
So whenever you do this equation, you actually can put it in either order. You'll get the same answer. It won't matter if you do the blue one first or the pink one first. That's a really good question. I probably should have mentioned that.
I think that's where I was getting most confused. I'm like, I don't even know what order to put it in. I really just been writing down what you put on there. 'cause I don't know.
Okay.
I don't know.
No, great question. You can put them in either order. It will give you the same answer. So
Okay.
that part doesn't matter. Yeah, no problem. Okay, so we've got them set equal to each other. Now what should we do?
0.5 like terms.
Yeah, we want to combine our like terms.
0.5 for both sides.
Okay, now y'all saying stuff I understand.
So here, quick reminder, like terms. So term is just another word for a number, basically. And the reason we say term instead of number is because a term can sometimes include these letters or these variables. So whenever two terms or two numbers are like terms, it means that they have the same variable. So we can combine them because they have the same variable. So I have 0.5x over here, and then I have negative 2.5x over here. Since the variable's the same, we can add and subtract them together. So would we rather add 2.5x over here to get 3x, or would we rather subtract 0.5x to get negative 3x?
Plus 2. Or 2 point.
Let's add. Let's get positive numbers. So plus 2.5x over here plus
You can do
2.5.
either way though, right?
You can do either way. Both ways will
Okay.
work.
Cross the 2.5s.
Yes, my 2.5s cancel out. Beautiful. And 2.5 plus 0.5 is 3. 3x. And then what do I do?
Bring everything else down.
Yes, bring it all down. Plus 5 equals negative 1. Okay.
It's been 1 plus 1 on each side. I mean minus 1.
So you could add 1 on both sides, but if I add 1 over here, then I'll have 3x plus 6 equals 0. Does that help me get closer to finding x?
No, so yeah, like you said, the 5.
Yeah, let's get rid of the 5. Let's try to get x by itself. So add 5 or subtract 5?
Subtract 5.
Subtract 5. We always want to do the opposite.
So 3x equals
And
negative
5
6.
cancel.
Yeah.
Yes, so then I have 3x equals negative 6. Okay.
Divide.
Now we divide.
Yes.
Basically, like, what's simpler after the
Yes.
Divide by 3.
Divide by 3.
Negative 2.
Good. So x equals negative 6 divided by 3 is negative 2. Ooh.
Thank y'all for saying like terms, and I started paying attention. It started clicking.
Good. And really, I love it when you guys ask questions because that's going to help you learn. That's going to help your classmates learn. I don't ever want you to be sitting there lost. You can always ask. I won't ever be frustrated with you. Yes.
You, Thor?
Okay, so I did something different. So I did negative 2.5 over.
Okay, so here, let's write out what you did.
It gave me
0.5x plus 5 equals negative 2.5x minus 1. So you're saying you subtracted? Oh, what'd you do?
I totally lost the negative to the 2.5.
Ah, I gotcha. Yeah, it's easy to make little mistakes like that, but at least you caught it. All right, so we don't need that anymore. So we have our value for x. How do we find y?
Let's put negative
Let's
2
plug
in
it
the top
in.
one.
Yes, okay, let's use the top one, sure. Let's use y equals 0.5 times
Negative 2.
negative 2 plus 5. And what is 0.5 times negative 2?
Negative 1.
Good. Negative 1 plus 5.
Oh, that'd be 4.
Gives us 4.
And y equals 4.
Which one did we just do?
We just did numbers 8. And look at that.
Like
X is negative 2, y is 4. We can do it. We're doing it, guys.
About that.
So our answer is -2, 4 in parentheses. That's our coordinate. Good. Don't forget that last part. Writing it as a coordinate. That's important.
I'm ready for my exit ticket.
Yeah.
I need a little time. I don't want to be the last 10 minutes and have to rush to get it done. I need
No, I'll make sure to give you guys more time
about
today.
15 minutes, please.
Okay. So let's see. How are we feeling on a scale of 1 to 10 about the substitution?
8.
8.5.
Like a 5.
Okay, maybe like a 5. We got some 8.5.
About a 7.5.
Okay, that's good. We're all 5 and up. That's good.
I'm in a 10 for that.
I'm
I'm
happy
in like
with
a
that.
9.
We know the joke.
Good. Good, good,
Right.
good.
Yeah, last
Just
term.
don't not, y'all bring my way.
Just do it.
There too.
Okay.
Okay.
So we feel good about substitution. Good enough for now.
Excellent. We feel good.
Can we talk about elimination?
I don't know.
Can we try it?
We can attempt it.
Let's attempt it.
We're about to do something else?
Yes, we are.
Attempt it.
Oh my god.
Elimination.
We're gonna attempt it, at least.
Let's attempt it. We'll see how
There's
we
more
do.
notes. Just doing more notes.
Yeah.
It is.
Elimination.
We're
The
doing
genius
like
man
examples
elimination is a
together,
lot easier.
so
All right. Okay. All right.
I'm trusting you.
kind of
I
yes.
hope so.
Okay, so let's start one more new page.
These quiz, I need every note.
5 pages is insane.
I know, right? I know.
Okay, so can I ask a question real quick? All
Yes.
3 of these ways, by graphing, by substitution, by elimination, all of them give you the same coordinate.
Yes. Same answer. Oh,
And we've learned 2 so far. Graphing and, okay, all right. Let's, okay. Damn it.
For what
This book.
purpose would we want to know all 3 different ways?
for what purpose would we need to know all different ways? So the purpose of knowing all 3 different ways
These quizzes.
in life, I guess, would be,
Multiple ways to
so
solve
if you are in a career where graphing and, solving for those variables, typically more engineering type fields, there might be a scenario where you don't have access to the ability to graph something, so you would want to use one of these options. The other reason you want to know all 3 is for both of the first 2 options, we've been using y equals mx plus d, the slope intercept form. Number 3, the elimination method, is typically seen with standard form, ax plus by equals c. So if you were given an equation in standard form and you didn't know how to convert it to slope intercept, then you would have another method.
Okay.
So yeah, good question. Okay. Page 5. Goodness. We're kind of making up for the lost time from yesterday a little bit. That was kind of wild.
It's called punishment, guys.
Oh my goodness.
No, it was here. We just was not together. I don't know. It was all day.
We tried something
Cut
new,
class
that's
and
why.
everything.
But I like the new thing. It was,
It was decent. I was able to follow along.
Yeah.
Once I learn how to use it properly, I think it'll be a lot better for
Like,
our class.
it wasn't even us yesterday. We just couldn't figure out how to use the ISO.
Yeah, that was my fault. I'll take full blame for
no, we
that.
appreciate it. I mean, I had something to do and I
All right, well, there you go.
You allowed us to catch up on English.
You're good.
You allowed me to catch up on my coursework.
Hey, that's necessary sometimes.
I still ain't caught up, but I was able.
You're doing good there. You got it.
Okay.
Yes, Lord.
So now let's look at elimination. I'm using purple.
Purple Urkel.
Yep.
Yeah.
Why did you feel the need to do that?
Okay, so with the last 2 methods that we were using, the graphing and substitution, we were always using equations in this form. You would have y equals a number x plus a number. Y equals an x plus b. There is another form of linear equation, though. That's what these are called, linear equations. Equations that can be graphed into a line. That's why they're linear equations. So the other form is usually used in this elimination method. So I'm going to say used for standard form. Which is AX plus BY equals C. And if you were in Algebra 1 last term, you might remember that we did some manipulation with the A, B, and C, and we could rearrange it into, what is it, negative B over C is the slope, or no, C over B, something like that. I don't know. I don't remember off the top of my head. But there's all sorts of ways that we can rearrange this into slope intercept. But for now, let's pretend we can. I'm going to give you an example. Let's say I have 3x plus 2y equals 5. And I don't know if we're going to get whole number answers. I am kind of making these up on the spot, full disclosure. And I'm going to give us an easy one first. Then we've got negative 3x plus 6y equals 18.
Last question.
Yes.
Why is it 6y? Why is it not?
Oh, I just made the numbers up.
Oh, okay.
I just made them up. These are just random numbers.
Okay. That's probably, I'm trying to figure out what they do.
Yeah. So these are the two equations. 3x plus 2y equals 5. Negative 3x plus 6y equals 18. So in elimination, we're doing exactly what the name says. We're going to eliminate one of the variables so that we can solve for another.
3 minus 3.
Yes. So I've already got my equations stacked up real nice. And all we're really going to do is we're going to add them together. So what's 3x plus
Zero.
negative 3x?
Zero.
They cancel. We got 0.
Because that is 0.
Yeah, so there's no x's left. I got rid of all 3 x's. Gone.
So
So
That's not
nothing.
right.
You don't have to write 0.
You almost got a whole.
8y.
Now what is 2y plus 6y?
No, we got 8y.
8y
Look at 23.
equals, and then 18 plus 5, you said 23.
23.
Okay, beautiful. Now
Divide 8, 23.
divide by 8. Divide by 8. And
Oh, yeah.
I'm going to get y equals, what's 23 divided by 8?
2.875.
What is it?
2.875.
2.875. There's my y.
Boom. Second.
How do I find x?
Plug in the Y.
Plug in the y for either equation. Let's do the one with smaller numbers and all positives. No. This time, be careful. We found y first.
So it's going to be 3,
So don't put it in the x.
2.875.
Oh, you just did it.
Oh, you're right.
So be careful. We know y. We don't know x. 3x plus 2 times y equals 5. So this time we have y, which is 2.875. Okay. What should we do first?
Multiply them together.
Multiply.
Yes, let's multiply 2 times 2.875. And that gives us
5.75.
good.
What's the answer?
5.75.
Thank you. I'm just copying.
5.
It's all good.
And now what do I do?
Divide.
Bring it all down, guys. Bring it all down. So equals 5. And then we still have 3x
Do we don't bring the
plus.
down?
Yes, we do. We do.
So you gonna minus 5.75?
Yes. We're going to subtract 5.75 from both sides. Minus 5.75 cancels it out. Minus 5 point, yes. So now we have 3x equals negative 0.75.
Not a lot.
We're gonna divide.
3
Divide by 3.
Negative 0.25.
Ah, yes.
Hello?
So x equals negative 0.75 divided by 3 is negative 0.25. Very nice. Very, very nice.
Hey.
Still iffy.
So how would we put that into
Yeah,
parentheses?
how do you put this?
The y is the
So,
0.25.
we should-
Now, let's write it as a coordinate. What value comes first, x or y?
X.
So
X.
the y was 2.8.
Negative 0.25, comma, and then our y, 2.875. That's our answer.
Could we use a equation from our paper, or is that not possible?
We could.
All
Let's see.
specific coordinates ever.
Let's see.
Too far. Like, how will we check that?
Well, that is an excellent question. There is a way to check this. There is a way to check your answer. I'll show you. Okay. So the way to check is I'm gonna wait to type it in. I'll write it out first. Takes a little longer to check. I'm gonna plug both of these in to the equation and make sure that my equation is true. So I have 3 times x plus 2 times y is equal to 5. So whenever I plug in negative 0.25 for x and 2.875 for y, and then I add these numbers together, they better come out to be 5.
Okay.
Let's see. So 3 times negative 0.25 negative 0.75 plus 2 times 2.875 5.75 equals 5. And what do you know? When you add those together, you do get 5. And 5 equals 5 is true. So your answer is correct. So you can check your answer. Even if there's not a graph, just plug it back into the equations and make sure that you get a true statement at the end. And this is true. 5 does equal 5.
Please don't make us do that.
Where did?
Okay. Okay. I don't have my watch on today.
132.
132.
132.
I think we need more practice.
No.
With elimination anyway.
Yeah. Well, she said we'd attempt it.
Yes, we were just gonna attempt it today. Now,
We're probably gonna go over it tomorrow, but well.
we will. We'll definitely go over both of these on Monday, a big time, especially because we just did it today. Here's what I would like for you to do. I'm gonna give you lots of time,
I have it.
and I'm gonna give you an exit ticket. That's okay. If you need to go, you can go. This exit ticket isn't due for another week.
You need to put a bonus question on there for elimination.
Actually, yes, I am gonna do that. It's bonus. Optional is
You don't have to, guys. It's optional.
optional. If you don't want to do it, don't. But you shouldn't be
But if
tempted.
you have a
It won't hurt
decent
you.
grade, I would do it.
Yeah. It won't hurt you, but it will help.
I gotta be.
So
That's what you
this
have.
is, and if you want to wait after I write this, I'm gonna make copies. So if anybody wants to, take a bathroom break while I'm writing this, you're welcome to. or you can copy it down with me. I am gonna make copies
Oh, so you
after I
can,
finish.
I'll wait for your paper.
Yes, yes, I'm gonna make copies.
I like
Oh,
to
So
see
day
it well.
22,
Makes it all-
exit ticket. And this is due on Thursday, December 12th. That's in a week. And please write your name on it if you take a copy of mine. Here, I'll give you a little name. Not perfect, but you know. Okay. Let's see. Let me give you something that I know will be nice. So, I want you to solve the system of equations using substitution.
Oh, it's so loud.
I don't know. Then
I know.
graph your answer.
What?
So I'm gonna give you another worksheet I can use as an string. That's the same one. It's on the same paper, Henry. Let's do
What's the bonus part?
As you
an
can tell, I love
elimination
the pop
problem.
too, but.
So y equals half x plus 5 and y equals negative 5 over 2x minus 1. So whenever you graph, the fractions will be helpful, but I'm also going to, remind you whenever you do substitution, sometimes it's easier to work with decimals. 1/2 equals 0.5. Negative 5 over 2 equals, what is that, negative 2.5?
Yeah.
Okay, so there's your fraction conversions if you want to use them. And I am going to draw you a graph as well. Let me think about it.
Oh.
Okay, so I need to give you at least down to -6.
So we only got one problem.
Yeah. Just one, because I know these take a while. These take a while.
Substitution, baby graph or answer. Isn't the answer on the side? Oh, no, it's not. Sorry.
Drawing a graph for you.
She can actually draw a pretty good graph.
Your time.
So that's all the necessary information.
That is all the necessary information. I haven't written the bonus question on there yet, but I'll do that separately. Okay, so let's see. 2, 3, 4, 5. 7, 8.
Take a picture of it when I finish it.
Good. These are not perfect, but I'm gonna have you guys number it yourself. I'm sorry. It's just gonna take too long if I.
You're good with that right there.
Perfect. Okay. Okay, be right back. I'm gonna freeze the screen in case anybody's writing it themselves. But but I am gonna make copies of this for anybody that would like it. So I'm actually just gonna make like 30 of them, but that is all. I'm gonna end the video there too.